So hello and welcome everyone to the new video of the module 7 digital electronics. In this video we are going to do the number system conversion, and this time we are taking octal to binary number system conversion. This is the part 3 of the number system conversion. So if you have not seen the previous videos, I highly recommend you to watch that videos and come back to this video. The link of all those videos might be flashing on the I button, might be over here, so you can click on the I button and watch those videos and then come back to this video. Okay, now let's start this video. Basically, as you have seen in this video, we are going to do the conversion from octal number system to binary number system, and same from binary to octal. And just to do this, we just need to understand that octal number system is basically having 8 symbols, that is 0 to 7, as we have discussed in the first video. Similarly, binary number system is having 2 symbols, that is 0 and 1. Right? These are the basics. The main key to do the conversion from octal to binary is to know the binary of 0 to 7. In the first or second video, we have discussed the shortcut trick to remember the binary of the decimal number 0 to 15. For octal, as the symbols are from 0 to 7, we should know the binary from 0 to 7. Okay, for your simplicity, I will be writing the binary over here for 0 to 7. So for 0 it is 0, for 1 it is 1, for 2 it is 1 0, for 3 it is 1 1, for 4 it is 1 0 0, for 5 it is 1 0 1, for 6 it is 1 1 0, and for 7 it is 1 1 1. Now let's jump to the example of doing the conversion from octal to binary. Okay, so for this, the first example that we will take is, simple example we will take is 567. This 567 is the octal number and we need the binary conversion of 567. So here what you need to do, first of all, you write down the number. What is the number? 5, 6 and 7. Okay, very good. Now for each and every digit, okay, this is one digit, this is one digit, and this is one digit. For each and every digit, you need to write down its binary in 3 bits. Okay, just remember this word. For each and every digit, you need to write down the binary in 3 bits. Okay, so for 7, we all know the binary is 111, right? For 6, the binary is 110, and for 5, the binary is 101. And after writing the binary, when you join this whole number, right, that will be the binary of the number 567. Isn't it very easy? So the binary over here of 567 is 101, 110 and 111. This is very simple conversion, octal to binary. Similarly, hexadecimal to binary is also very simple conversion. Let's take another example. Right now, let's take a rational number. So the number that we will take is 437.123. Okay, so what I will do, I will simply write down the number first of all. We have 437.123. So what I will do, for each and every digit, we need to write down its binary, but that binary should be in the 3 bits. Okay, so 47, it is 111. For 3, it is 11, but we need to write down in 3 bits. So we need to add 1 0 over here. And I hope you understand that adding 0 before any number will not change its value. And now for 4, the binary will be 100, right? Here we are having 1 point. After that, what we are having is 1. Okay, so the binary of 1 is 1, but we need to write down the binary in 3 digits. So here also we will add zeros before the 1. Then binary of 2 is 10. It is again 2 digits, so we need to add 1 0 over here also. And binary of 3 is 11. So here also we will add 1 0. And by joining all these ones and zeros, this is your binary of 437.123. Now let's do the reversal. Let's say if you are having any binary number. Okay, I'm just randomly writing the binary number. It can be any bigger number. Okay, here I have written some big binary number, and someone have asked you to do the conversion to the octal. So here what you need to do is, first of all, you write down the binary number that is given to you in the group of 3 from the left. So from the left, if you make the group of 3 digits, so this will be your first group. I will write over here 101. This will be my first group. Then the second group again is 101. Okay, I will write down over here. Then the third group over here is 011. So that I will write over here 011. And the last group again is 101. That will also we will write over here. Now, what is the decimal of this 101? We all know it is 5. What is the decimal of 101? It is 5. What is the decimal of 011? It is 3. And what is the decimal of 101? It is 5. So this is your octal conversion. This is the octal number that you are getting, right? 5355. So this is your answer. Isn't it very simple? You just need to make the group of 3 digits from the left and you just need to write down its decimal equivalent. And once you do this, your conversion is complete, your conversion is over, right? Isn't it very simple? Let's take another example. This time let's take the rational number. Here I'm writing any random number. Okay, now what you need to do, see, as there is a point, you need to make the group of 3 digits, right? But the numbers that are before the point, for that you need to make the group from the left, and the numbers that are after the point, you need to make the group of 3 from right side. Okay, so in this manner, in this direction, you need to make the groups. So the first group is 0 1 1. I will write over here 0 1 1. The second group again is 0 1 1, and the third group is 1 1, right? But just to make the group of 3, I will add 1 0 over here. Now there is a point. After the point, we need to make the group from this direction. The first group that we will have is 1 1 1. The second group that we will have is 0 0 1, and the last group is 1 0. Okay, but here if you see, the last group is of 2 digits. So to make it 3 digit, we need to add 1 0 at the end. Why we are adding the 0 at the end? Because this number is after point number. So after the point, if there are some digits and if you add 1 0 at the end, it will not make the change in the value. So that is what we need to do. So now we just simply need to write down its decimal equivalent. All the groups that we have made, we need to write down the decimal equivalent. Okay, so here we are having 0 1 1 in all the groups, so it is simply 3, right? 3 1 is 7, 0 0 1 is 1, and 1 0 0 is 4. So your answer is 333.714. So I hope with all these examples you are clear in how to do the conversion from binary to octal as well as octal to binary. With this, we will end this video, and in the next video we will discuss how to do the conversion from hexadecimal to binary or binary to hexadecimal. Okay everyone, so with that, let's meet in the next video. Thank you very much.